Okay, perfect. Hello everybody. I'm Laura, as already was mentioned, and I'm working as a front-end developer at Swedbank. I'm working in Lithuania, Vilnius, and today I want to talk about. And people usually get really confused when we are trying to talk about how we can code music. And despite that, how we can code visuals, it's very common sense so far. So today I'm going to show you that, and please feel free to try as well together, open same as I will open, and just try together that. And I'm always when I'm talking about how we can code the music, I'm always asking about the audience. So please write now in the chat, are you a musician or are you a programmer? Maybe you're both in one, or maybe you're none of them. It's very just interesting to know. So please leave that in the chat. Why do I ask that? Because when we are thinking about how we can code music, people think that you should be a musician and programmer. And yes, both knowledges, they are for sure advantages, but to start doing something with music programming, you do not need any of that. And I would say that this can be as a perfect way to start learning either about musical or programming sides. So I see that majority are programmers. Okay, it's very interesting to read. And this one we can dive into. 1843. 1843, this is the year then music programming as an idea was already introduced. And as you may see, that we did not have the computers as we understand them today. But despite that, at the level, and she already described in her works about how we can code the music of the machine we had at that time. And no surprises that nowadays we have different ways how we can code music and different programming languages for that. Today I'm going to talk about two totally different programming languages. The first one, universal programming language JavaScript. I'm going to show you how we can do live coding. That means how we can create and change music on the fly. And as well, how can we incorporate that to our daily basis web applications. Then I'm going to talk about totally different programming language, the language which was specially created for music programming. It is Sonic Pi. And with Sonic Pi as well, I'm going to show you how we can create some live coding. And let's start with JavaScript. And for that, we need to meet Jibber. Jibber is browser-based creative coding environment for audio-visual art. And today I'm going to focus only on audio part. So nothing to download is needed. It's simple. You as well can go to jibber.cc and you're going to see the environment itself. So this is Jibber. Quick information that on your left you can find different some sort of tutorials, demos. You can just click on them and play it. And the full right is for coding. Let's start with something simple, as we all usually start with some Hello World applications. In music programming, we have the analogy of that, which is called first beep sound. And for first beep sound, I'm going to use oscillators, which are periodical waveforms. And here, I'm simply creating the object of the oscillator. I can write new, as it is more common in the JavaScript, but in the Jibber, I can simply emit it. And at this point, I can already run my program. So hopefully you hear the sound. I can run it again. All good. Okay. So this is our first beautiful sound, first beep sound. And I'm running it and stopping it manually since it's periodical waveforms. And this is very beautiful, but how can we change that? Because how can we change that in order to create the music itself? And for that, we need just a bit to look into the physics side, because what do we want to change? Physics saying that sound is vibrations which travel through some sort of a material. And that material is usually just an air. That means in order to change the sound, we actually want to change vibrations. And how can we do that? There are a few options. The first one that we can change the frequency of this of this vibration. That means how often molecules should go back and forth. And the differences, we can get the lower or higher pitches. As well, we can change the amplitude, how far molecules are moving in vibrations. And that we can get quieter or louder sounds. Keep an eye that there is the range in which we need to manipulate, because our human ears have some limitations. How can I apply all these changes in Jibber? I just simply need to provide this kind of configurations during initialization of this object. And for example, I can say that I want to have frequency 600. And I hear a bit different sound. The question for you, please write in the chat, what do you think? But if I would change 600 to 400, how many of you think that we will get a lower pitch? And how many of you think that we will get a higher pitch? Okay, lower. Let's try. Yes, this is lower because we wrote lower frequency. And at this point, I need to tell you one interesting thing. I can as well add that to the variable, because it's simple moving to the variable. And if I will rerun my object creation with different parameters, observe what happens. But if I change my one-letter variable, it's not one-letter variable. Why did that happen? And why did we hear now all sounds playing together at the same time? If you have an answer, please write that as well. But the answer which I found, that this is a mystery. And this is really what documentation says, that the reason for this remains mysterious, but the problem is to be revealed. So let's be aware of this different namings, and we can move forward. Because I mentioned that we can change the frequency, but we can change the amplitude as well. So for example, I'm having it like here. I can change the frequency in this way as well. And amplitude, it's a bit in different way, because for frequency we were writing the same measures which are in hertz. For amplitude, we will not write that in decibels, but in Jibber we are using Jibber measures where the quota would be as a default sound. So let's have something less than quota. And something more. And this is the basics which we can, what we can manipulate, but there are more advanced ones as well, which we can use together. Okay, a bit too much, but you hear that we are changing now the instrument. And the sound itself is different as well. And there are different, some sort of instruments which we can use in the Jibber. And one of them are special ones, which are called sound font. And for sound font creation, we need to say what kind of sound do we want to have. And now I'm saying that I want to have classical piano. And now I'm creating only the instrument, and I need to say what kind of notes I want to play. So let's have, for example, 660. And in this way, we can already start to create some sort of even known melodies. Just To play with hertz, as I did, it's pretty tough because you do not know by heart what kind of note it is. And there are an easier way to do that, because in musical wave we can express notes by letters. What do I mean by that? That instead of saying that this is 440, I need to say that I can say that it is a note in 4th octave. And we can do that with different notes. In Jibber, we can as well apply this. That is working with all synthesizers except sound font. That's why I'm coming back to synth. I am taking bleep, different one, not the default. I will add a bit more volume since it is quieter one. And let's have 440. And if I would change 440 to A4, we hear totally same sound. Another optimization, if we are looking here, that so far I'm always running the same note. So with every change, I should rerun my program. And there is more advanced way to do that. We can actually provide the list of notes, what you want to play, and as well how long each of the notes should take. So 2 lists we need to provide. And instead of saying note, I can say play. And now I need to provide 2 lists. So let's have, for example, E3 note, 3 time. And then another list to say how long each of them should take. And even when I'm going to run it, you will hear that we will have the repetition of these notes by default as well. What do I mean by that? Okay, what I just did here, thank you. I wrote more notes and more times, as you see it here, and I simply reran the program, and we heard the difference. And as well, we have that repetition by default. Then I moved my notes and times to separate variables because I wanted to reuse them for different instruments. I created mono here, and I simply used same notes, same times here. Lastly, I added new element in Jibber, drums. Drums are one of the most popular, I would say. You always using drums somehow. And for drums creation, you need to provide what kinds of drums do you want to have. You can have open, closed, hi-hats, kicks, and snares. And as well, you need to say how long each of them should take. So I was taking firstly 1/8. And this is how we can add instrument by instrument and to create the harmony, to create the melody, and to add different instruments with different notes mixed up, and so on and so on. And probably you already noticed that actually to write the exact notes and exact times usually taking the most of the time. And due to that, I prepared another example to show how even more sophisticated music may look and sound like. Okay, what do I have here so far? I importing some speaking library at the beginning, but then I having pretty similar thing what I already showed you. Times and notes. I just have more of them. And I'm making some with a concatenation, some other notes, other times, and there are a bunch of them. And then I'm simply creating 4 different instruments here. I am providing different configuration for them. Then we have drums here. And then I'm simply playing different melodies with different instruments here. And keep an eye, I'm going to introduce the last element in Jibber, which are effects as well. Rock and roll with code. And that's all with Jibber. And this is how we can add different instruments, different melodies together. When we're having the notes and times prepared, it's even faster going on. But I promise for you that we're gonna look into another way how we can use JavaScript to create some music. We can do the same thing into our web applications. And if we are talking about music possibility in the web, about audio possibility in the web, that is nothing new. We had different ways how we can do that. But today I'm gonna show you, I'm gonna talk about the most sophisticated way to do that nowadays, which is Web Audio API. And why it is so great? Web Audio API, it not only enables us to replay some sort of the audio track, it enables us to create our own sounds, to modify and analyze them as well. And the general picture is pretty simple, that for the web, we would create audio context and everything would happen there. We would create the source, that can be our same sine oscillator, that can be our microphone or audio track as well. And we would need to connect that to the destination, which is usually just a speaker. So this is the general idea how we could enable our own sounds playing in the web. And if you would ask me, how could we create our same first beep sound just from browser console? So it's just with these few lines. We would create the audio context, then simple, we would create the oscillator. This is the example. I'm creating the same sine oscillator, which we used in Jibber. And then I need to connect that to the destination and start it. So in these few steps, we would have the same first beep sound. And yes, that's a bit more writing than in Jibber's simple write sine, but we do not need any special environment as Jibber. It is just simple our browser console. And of course, we developers, we love libraries, and there are libraries for that as well, to make our lives a bit easier. And one of them is Tone.js. Tone.js is even recommended if you're reading about Web Audio API in MDN documentation. It is helping us to make everything faster. And I was actually very surprised how easy it is to work with Tone.js, and prepared one small demo here. One second. Okay. What do I have here so far? So here I'm having a simple Angular application, and I'm going to show you how we could create some sort of the instrument, to create our own instrument. And so far I just installed the Tone library. You see it here. I have instrument component, and in the instrument itself, I have a bunch of buttons, which is calling same play node function. And in the function itself, what do I have? I'm triggering the node. The synth is coming from the Tone library, and I'm triggering that with 1/8 the length. And then I'm just simply playing whatever comes to the function. And how does that look and sound like? So we have here the instrument, which can play any melody we would like, because we have a full range of the sound. Just that's a bit maybe default sounds which we're having from the synthesizers. And for that, I thought that we could look into a bit more original sounds. And I changed that a bit. So what do I have it now? So we still have a full range of the instrument, but it's playing now cat samples, but still according the right note. And I was surprised how it is easy to make that, because in my imagination, I thought that I would need to change every sound by myself according the right note, and then just to connect it with the help of the Tone library. But that was way easier than this. HTML did not change much. I'm still iterating for the bunch of nodes, which I'm hard coding here. But what do we have new? It is sampler. Sampler as well coming from the Tone library. And for sampler creation, I had to provide what kind of sample do I want to play. So I provided the original cat sample and then connected to the correct note. So to understand what note cat was singing, that was tough. But it was G2 according to what I had done. And nothing more was needed to provide for Tone library because it was handled by default. All other sounds was handled according to right pitch. So that is pretty easy, and we have now the original, our own instrument. And some of you may think, cat sound instrument, how useful it is. But don't judge me too soon, because for those few of you, I went an extra mile and I created something special. So we have here Doggy-on instrument, which is plays dog samples, but still according to the right note. But not only this. So these different sounds, we can create the tone library. And just briefly, I want to show how can you make it that as well. There are different elements which you can take from the tone. And I already showed you that there is a sampler, there is the synthesizer, but so far I was using the default. And here I a bit added more configuration. So for example, we can have different synthesizers as polysynth now. And before we were always using the oscillator, sine oscillator. Now we are having here square oscillator. And then we're simply connecting the different volumes, so we can as well adjust the volume and then to play the different volume for that. Then going forward, we have the melody part. A melody part itself can be a bit tough at the beginning to grasp, but actually it does nothing more than just plays predefined notes of the predefined instrument. It's like the part of the melody. And here I'm playing the sampler, and I'm having a synthesizer, synth saw as well here. And then I'm playing the melody chords. And I have this function as well. I can toggle it. I can as well have the loop on top on everything and change as an element how it can play. About the chords I'm taking from here. I'm predefining the chords. I'm predefining when each of the notes should play. So if I'm playing a few different notes at the same time, this is how we're making the chord itself. And I can as well say how long each of the notes should last. Then we have the bass part here. And there is one interesting noise. Noise is as well another element in the tone library. Here I'm using the pink noise, but I'm not playing that straight. I'm adding some filter. You see it here, auto filter. So I'm creating some sort of the waving effect on top on the everything. And then back to basics, I have some samples here as well. I'm playing Mario samples, taking the randomly which one I want to play. And then as well, I can speed up as we saw as well in the Jibber, and I can stop everything. So there are different elements, and we can configure them in different ways in order to create some sort of a melody we would like. So this is how we can use tone in the web, and we can create music in the web. And usually when we are thinking about the front-end development, our full focus is only on visual part, and sometimes we even forget that we have audio possibility in the web. So please note that sometimes the audio can really enrich even our UX part. But going forward, I promise to you that we will talk about JavaScript and another way how we can create the music. And it is time to talk about Sonic Pi. Sonic Pi is the language which was specially created for music programming, and it was created firstly to provide it at schools, that children would start in that way to learn about the programming. But at the time, it became so popular that people even started to use them to make some sort of the performances. And you can Google about algorithms or other events where just developers are going and performing the code, some sort of music. And today I as well going to show you how can you do that. So the first difference that the Sonic Pi is coming together with the IDE. So you can download the full IDE, and this is what you see here. And let's start as well with something easy as hello world, the first beep sound. So in Sonic Pi, we are writing as play 60, and at this point I can as well play it. So hopefully you hear it, right? And this is how we can have a third beep sound. But Going forward, of course, there are more advanced ones as different synthesizers. And here I have another example that we can have same like classical notes with the piano, for example. And as well, we can provide the list of notes, list of times. There are some similarities which you already saw. Going forward, another element in Sonic Pi is called samples. There are different kinds of samples which are actually some sort of the audio tracks, and we can as well modify them or play them together. So here I'm having two different samples. And you can see that there are many different, and you can just choose some of them. Going forward, on everything what I just mentioned, on the synthesizers, on the samples, we can add the effects. Effects we're adding as a, for the block, what is inside do and block, this effect is applied. So here I'm adding a slicer effect. And I can change it to a different one. So there are different ways, different elements to get the different melodies. But so far I'm always playing one melody, and that is finishing very fast. How can we have some sort of the repetition? In the Sonic Pi, there are no default repetition, which we had in the Gber before. We need to use loops for that. And there are different kinds of loops. The first one is when we are saying how many times do you want to repeat that. For example, 2 times. But I can as well have an infinite loop. And in music programming, this is really what do we want to have, because now our result is in the time. So I can play it, and then whenever I want, I can stop it. And at this part, we have a melody which is lasting long. How can we make some harmony? Because so far we have only one melody. And the easier thinking that let's have another loop. Let's have some sample, like maybe drums. Let's have drums every second. And the question, one more question for you guys. Write the answer, what do you think? But if I will run the program which you see it now, will we hear both melodies playing together? This is a very tricky question. Some people thinking that no, some people thinking that yes. Okay, let's try. We do not, because this is how loops work. We are moving from the first line, and we are always stuck in the first loop. And at this point, we need explicitly to introduce some sort of a concurrency here, because we need to play those two melodies in parallel. And in Sonic Pi, we have for that special loops. They are called live loops. And for live loops creation, we need to say, we need to create the name to make it unique. So for example, let's have it melody here. And let's have drums. And now we can actually hear the two melodies playing together. But let's hear something else. Did you hear the difference? Did you hear that I simply changed the instruments to piano and just reran the program? We did not hear any stopping or the losing the beat, because that was changed on the fly according the right rhythm. So this is the live loop is taking that and handling everything. And live loops are the key thing of Sonic Pi, the key thing of live coding, because we can change the music on the fly, and we can play different melodies together at the same time. And I'm going to my last example of live coding. What do I have here so far? I want to introduce that at the beginning I have a bunch of notes, and a bunch of times I'm just describing them here. Then I have the function. I have the play chord cycle functions, which I'm calling from the chords here. And then I have different live loops for introduction, for bass, for drums. And sadly, I did not get the good microphone today, so this part will be skipped where I would be singing. So probably I can even remove this part. So what I'm gonna do now, I'm gonna play this one and change the music on the fly. You can as well, during that time, download maybe Sonic Pi and try it for yourself. Well, that's all of Sonic Pi. This is how we can do live coding using Sonic Pi, which was specially created for music coding. And actually, that is all from my side. That is all content which I want to show you today. But if you have any more questions now or even later on, you can always reach to me. Thank you.